This is Sanjay Gangal from EDA Cafe from our Silicon Valley headquarters studio. I'm here with Sundar Iyer, co-founder and CEO of Memoir Systems. Hello, Sundar.
Hi, Sanjay. Thank you for having me here.
Well, Sundar, thank you very much for coming over. Can you tell us a little bit about Memoir Systems?
Sure. Memoir is a 4-year-old company. We're focused on the memory performance problem. We got our headquarters here in Santa Clara, and we have a design center both in India and Armenia. We focus on this age-old problem of the processor memory gap, which has become a pretty pressing need, especially today in the terabit processing era.
What is terabit processing problem?
If you look at some of the applications today, they are moving to the cloud. We have examples of extremely high bandwidth applications, such as Hulu Plus and Netflix. The standard high bandwidth applications, such as Gmail and iCloud. And ultra low latency applications, if you look at Skype or Google or Bing. Each of these require high amounts of bandwidth and low latency. Now, data centers have figured out a way to solve this problem by doing server virtualization and multi-core processing as far as compute is involved. However, we need the network to be able to meet these demands. And unless we're able to do that, to meet this terabit scale data processing, the promise of these applications is still born.
What are companies doing to address the challenge of network performance today, and what should really be done?
The standard approach today is more is good. So more servers, more routers, more switches in the data center to scale to these demands. This is not a scalable approach because eventually the amount of area required and the amount of power that these equipment consume will cause breakdowns. The correct way eventually is to increase the density and the capabilities of processing on a single SoC. So we're looking at customers who want 40 to 64 ports, each of these ports running at 40 gigabits per second, so that you can do of the order of 3.2 terabits of bandwidth on a single SoC.
What makes terabit processing so hard?
If you look at any application on an SoC, it's really gated by 3 things: the amount of processing horsepower, the memory operations available to it, and the I/O bandwidth. It's well known today that memory performance is the laggard. And as we go to terabit scale processing, the memory performance lags by almost an order of magnitude to what is needed in terms of aggregate processing performance. And that's what makes it so hard.
Can you give us more specifics about the memory challenges?
Sure, Sanjay. There's really 3 things that make the problem really hard, and they're all to do with memory, of course. First is the sheer amounts of raw bandwidth. It's kind of well known that networks grow at about 30% per annum in terms of bandwidth. However, when we look at customers, because of density, cost, and integration pressures, we see customers requiring 200 to 400% more bandwidth just to integrate the sheer number of ports. In fact, we have a customer we talked to who was doing of the order of 480 gigabits per second of bandwidth, and in the next generation, they've gone beyond 2 terabits in performance. So number one is the sheer amount of bandwidth. A second and key reason is the amount of area that memory uses. It's well known that most SoC area today is dominated by memory. Over 50% of all area is memory. And we're seeing chips which do 60 to 70% dominated by memory. Last but not the least, it's the age-old power problem. Chips, even in the last generation, were doing 40 to 60 watts of power on a single SoC. Imagine taking that and pushing its performance by a factor of 2 to 4x. And now you have chips that are literally breaking the power budgets. So terabit computing has literally become a big deal. You've got the age-old problems, performance, power, and area, that has just never really gone away. In fact, it's almost come back with a sting in the tail today.
How is Memoir going to solve this problem?
We've been at this problem for almost 4 years now. We started by trying to solve the age-old processor memory gap, and we introduced algorithmic memory technology, the idea being we take existing physical memory, add RTL in front of it, and increase random access performance by a factor of 2, 4, even 10x MOPS. We call the product Renaissance algorithmic memory. We introduced Renaissance 2x to make memories 2 times faster, 4x to make memories 4 times faster last year. And just October of this year, we released Renaissance 10x to make memories 10 times faster. However, what we've noticed is as we've now talked to customers doing terabit scale processing, even an order of magnitude memory performance is in some cases not enough. And this means we've now had to come up with a new approach to solve this problem.
What is this new approach called?
We call the new technology pattern-aware technology. It's literally an eponymous name, pattern-aware, meaning we're aware of the patterns going in and out of memory. And this was motivated from the observation that if you look at datacom memories, not all functions require purely random access behavior. In some cases, there are specific patterns. For example, if you look at a packet buffer, the writes that you do to memory are not constrained. Or if you look at a policing or NetFlow application, they do read modify writes, which means that the write always goes to the same address that was read a few cycles back. So we decided we could take advantage of these patterns, and we built pattern-aware memory on top of our algorithmic memory technology. And this allows us to scale the performance by almost 16 times the essential clock rate of the memory. The other thing that pattern-aware technology does is it gives better area and power than existing solutions.
Can you give us some examples of how customers can benefit from using Memoir's pattern-aware technology?
If you recall, I mentioned this customer who went from 480 gigabits per second to over 3 terabits in second of performance within one generation. If you compare the clock speeds, this requires almost 16 times improvement in performance as compared to the clock speed on the SoC. And this would not have been possible without Memoir's technology. So we were able to provide a solution that both gave guaranteed performance as well as extremely low memory latency while maintaining over 3 terabits per second of bandwidth on the memory subsystem.
How does pattern-aware technology solve the power problem?
Pattern-aware technology exploits two important aspects of datacom applications. First, networks are not that utilized and they're not that congested, which means we're able to take banks of memories and put them into a hibernation mode, literally saving tons of power and only wake them up when required. Second, even when a network is highly congested, not all the memories inside an SoC are accessed simultaneously. This means certain aspects of memory can be turned off and turned on just in time, similar to what you can call as sleep mode in a laptop. If we take the effects of both of these power savings into account, we believe we can save of the order of 10+% of energy or average power consumption on an SoC. With 2% of all energy consumption in the US coming from data centers, this begins to add up to a lot.
What are some of the applications where Memoir's technology is being used?
I'd say we have several customers, mainly in the datacom domain. Over 65% of our customers are in datacom. In multiple segments there, Ethernet switches and routers, cloud infrastructure, storage networking, software-defined networks, mobile infrastructure, and the like. We've also had users outside datacom. HD video, which requires a lot of bandwidth and computation, uses us. And we also have customers in automotive.
How can people find out more about Memoir systems?
You're welcome to come to our website. It's memoirsystems.com, all one word.
Thank you very much for coming over and talking to us. Have a safe trip back.
Thank you, Sanjay.